and earn. So you have to earn are there are red, green, and blue balls. So what you do in step 1 is you choose one ball. You replace it. And then step 2 is you choose one ball again. So this is the first compound experiment. It says some urn and has these different colored balls in it. And so what you're going to do is you're going to take you're going to choose one ball, you observe the color of the ball, put the ball back, and you choose another ball. So the sample space here, it's like you have 2 experiments combined into one big experiment. So the sample space it's really going to be, so you could choose a red ball the first time and then a red ball the second time, or you could get a red ball first and a green ball second, or you could get a red ball first and a blue ball second. So, or you could get this green ball first and the red ball second, green first, green second, green first, blue second. Or you could get blue first, red second, blue first, green second, and then blue, blue. So this is like a compound experiment because you have basically 2 sub-experiments that are combined into this giant experiment. So you can draw a picture of this. A picture of this experiment. And it's called a tree diagram. Okay, so it's going to look like this. So I'm going to put this, I'm going to put a little omega knot over here. So don't worry about this for right now. So we'll put a little omega knot here, and then we'll have 3 outcomes from the first step. So the first step is you choose a ball. So the 3 possible outcomes, you can get a red ball, a green ball, or a blue ball. So we'll have a red, we'll have green, we have blue. Okay. So this is like the first sub-experiment. So it's the first step. We choose one ball. So there are these 3 outcomes in the first step. And then you're going to do this again. So if you picked a red ball, then you're going to go on to step 2 now. So there'll be 3 outcomes again. So you have this again. You have a red, green, and blue. If you pick the green ball, the first step, there would still be these 3 outcomes. You still have red, green, and blue. And then if you pick the blue ball first, then in the second step there would still be these 3 outcomes again: red, green, and blue. So if we draw this picture, you can see what the sample space will be. So this object in the sample space, this outcome RR, that's like if you took this string here. So if you went R for the first experiment and then R for the second experiment. If you took R for the first experiment and green for the second, that would be this one here. And then if you took R and then blue, that would be this. If you took blue and then R, that would be this bottom one. So if you look at this diagram, then the strings that you can form from going left to right and hitting these blocks, those correspond to elements of the sample space. Do you guys have any questions on this one? So let me give you the second compound experiment. So this is compound experiment 2. So now we'll have an urn that are very considered is exactly one red ball, one green ball, and one blue ball. So what you're going to do this time is we'll have 2 steps again. So, step 1. You choose one ball. Okay, if the ball is red, you replace the ball. If the ball is green, you do not replace it. If the ball is green, you do not replace the ball. If the ball is blue, then you stop the experiment. You stop this experiment and you do not perform step 2. So that's step 1. And then step 2 would just be choose another ball. So, step 2 is you choose another ball from the urn. Let's draw a picture of what this would look like. So now what you're doing is you've got this urn. It has one red ball, one green ball, one blue ball. So the first step, you choose a ball. If the ball is red, then you put the ball back. Okay? If the ball is green, then you just keep the green ball out. And if the ball is blue, you stop the experiment. So, draw the diagram. So I'll put this omega naught here. So in the first step, what are the outcomes? What are all the possible outcomes of the first step? So red, green, blue. So in the first compound experiment, in compound experiment A, the outcomes in the second step didn't depend on what the outcome of the first step was, right? So in the first compound experiment, even if you chose red for the first step, then you would still get all three outcomes. Right? These three outcomes would still be possible there. And if you took the green ball first, then you would still have the three same possibilities for the next step. But here, if you choose a red ball first, then what are the possibilities after you choose a red ball? So now I'm on the second step, and I've chosen the red ball for the first step. So what are the possibilities here? Red. Still, if you choose the red ball first, then you still have these three possibilities in the second step. So what if you choose the green ball in the first step? What are the possibilities now? It's red and blue. So red. Blue. So you took the green ball out. So now in the second step, it's not possible for you to choose the green ball. There are only these two possibilities now. And then here, if you chose a blue ball for the first step, then you don't continue on. So this just stops like this. So if you look at this diagram, you can write out what the sample space would be. Sample space. Let's set omega. So it'll be all the strings you can form out of this diagram. So you can do RR, you can do RG, you can do RE, you can do GR, so GR, you can do GB, or you just do B. You guys have any questions? Go ahead and sign your name on this. Okay, so let me give you. Let me do this one. You guys have any questions on this? So now let's say the experiment is to flip a coin twice. So now this experiment is to flip the coin twice. So if you wanted to draw a tree diagram, of this experiment, it would look like this. So you have the first step, you flip the coin, so there's two outcomes, you head and tails. So if you flip heads, and now you go to the second step, which is to flip the coin again. So what are the outcomes in the second step? If you flip the heads first. So I flip the coin first, then the two options, it's going to be heads and tails, right? So if it lands heads, I flip it again, so what are the two possible outcomes if I get heads first? And then what if I get tails first, what are the two possibilities? Okay, this sample space. So it'll be these sequences H, HT, TH, and TP. So let's say the experiment was to roll, so Say you flip a coin 3 times.